Sorry if I rushed through that last one, but imagine I'm trying to find the area and I start at point A. And then I end at point A. That's not a very wide area, is it? I'm going from A to A. That's the same spot. The total width is about 0. Guess what the area is going to be? Guess what the integral is going to be? And then finally, the third basic rule that we have here is, what if I pick out some random point in the middle and I just happen to call that point C? Well, that means that the area from A to C plus the area from C to B, if I add up these two areas here, they should be equal to the area of the total from A to B. So basically, whether you split your areas up into multiple parts or one long section, it's still just going to represent the same area. And you can do this geometrically as well as using just the equation. We're about to learn about the fundamental theorem of calculus. And as you can tell by the name, that's pretty important. And that's going to be a rule on how we actually get the definite integral. How do we use that with just an equation to find this out? But let's take a look at some geometric ways of finding areas first. So here's a quick example. We've got a function, I'll call it f of x, and it's just basically a straight line right there. I gave you a couple points, -2, 0, 8, 5, great. What is the area under the curve from 2 to 2? Don't hurt your brain too much with this one. That's that first rule. If the width of my object is 0, I think the area is going to be 0. What kind of shape do I then get if I go from -2 to +8? Well, it looks to me like the shape of that is going to be some sort of triangle. I don't even need to know what the function is. I just need to know that it's going to be 1/2 base times height. Or in this case, 1/2 times 10 times 5. The area, or the definite integral, is going to equal 25. And I didn't need calculus to do that. All I needed was some basic geometric knowledge. And then, if I was to take the exact same function, but I start at 2 and go up to 8, how did that change it? You can do this one of two ways. I like to think of that and just say that is a trapezoid. I can find the area of a trapezoid by either taking the average bases times the height, or in this case, I'm going to take the average height times the base. That is 6 units wide. Whoops. I said I was going to take the base times the average height. So I add up the heights divided by 2. So basically, I have a base that is 6 units wide. If I just do a quick little figure here, I realize that that point is at 2, 2. Wow, 21. How about that? I did that without any calculus. You can use geometry to deal with this. And I'll look at just a couple more examples related to some of our definite integral rules. This function looks a little more complicated. Nah, it's still, basically geometry here. So I'm going to look at example 4, and I'm going to say, you know what? If I'm going from 0 to 6, I could think of this as a trapezoid. Or the second way I was going to mention you can do this is maybe you think of it as just a rectangle and a triangle. It could be that if we really just look at the rectangle there, which has a base of 2 and a height of 3, and then I look at the triangle that's right next to it from 2 to 6, and I add that up, that looks like it's 4 by 3. That would be an area of 6. Sometimes it's easier to break these up into smaller portions that you can determine. That's the case here, and this is the same rule that I had written down before. A to B is the same as A to C plus C to B. In the next part here, I would have to tell you that that is a semicircle, or actually a quarter of a circle. So then, how do you actually manage to find the area in here? Well, I would use geometry, and I'd say take the area of the square, the area of that square minus a quarter circle.